Hi there. So my name is Matt Sandoe. I'm representing OS Climate today. OS Climate stands for Open Source Climate, and we're one of the FINOS strategic projects. So in principle, climate change is representing a significant challenge for financial institutions. From one dimension, lenders and investors are having to understand the incredibly complex and volatile decarbonisation pathways that the world is taking, in particular with the geopolitical uncertainties presented by the American institutions, for example, or America dropping out of climate commitments, and you've got Russia. So there is a lot of volatility. So there's a need for firms to try to understand and make decisions on how we think the world will decarbonise. At the same time, the world is facing significant crisis in terms of worsening climate conditions. And what I mean here is physical climate conditions. So how does a lender or an investor adapt towards the increasing wildfire risks that we see, the increasing droughts, tropical storms, et cetera, And navigating those risks is quite significant in that field, in the sense that we could be facing a lot of mispriced assets that are hotel chains, for example, that we might be financing that could be underwater in 20 years' time for 30% of their occupancy. These are going to impact asset valuations today. It's going to happen. If it doesn't happen now, it's going to be within the next few years. The beauty is that as with the carbon transition and the way that the physical changes in climate work, it's also an opportunity for financial institutions to develop adaptation finance products. So when it comes to a challenge, that challenge is also requiring a significant amount of geospatial data handling that these organizations now have to work on. There's also a significant amount of open data and open models around the world that can be leveraged by organizations. So this makes the problem itself absolutely ripe for collaborating, because 90% of this problem is shared amongst financial institutions. Everybody has to challenge in terms of optimizing their geospatial data. Everybody has the challenge of incorporating climate science into their end-to-end decision chains. So what OS Climate is we are a community of collaboration, and we are bridging world-class technology with research, academia, and financial institutions. Now, I've mentioned carbon transition and data handling projects. All of these exist under the FINOS climate strategic projects. But today we're representing the physical topic, physical changes in climate. And it's an absolute pleasure that I'm going to allow Elena to introduce herself. But Elena comes from one of the core collaborating teams within OS Climate from a firm called Arfima. And today you're going to hear about what open source modules have we built, what do things look like, what are we thinking about it, but also you're going to see one of my favorite examples of collaboration where we've been working with IBM Research to open source some of their geospatial data handling code methodology, linking that with artificial intelligence in order to produce a wildfire model that we can open up to the world. So, so without further ado, let me hand over to Elena, and I'll be back for Q&A a little bit later.
Well, thank you for the introduction, Matthew. As he said, my name is Elena de Toledo. I come from Arfima Financial Services, and we're working within this OS Climate initiative, specifically in the physical risk library that we're developing all together to measure climate risk. So I'm pretty sure we all here are really familiar with what climate risk is, so I won't really go into the formal definition of what it is, but I do want to emphasize why one key piece of data that I think is crucial, and that is that one of the main implications of climate risk is that our climate past is no longer indicative of our climate future. This means that when we assess this type of risk, we must adopt a forward-looking perspective, and we must use climate projection and different scenarios when assessing this type of risk. So I think I can state here the world weather attribution that says that in today's climate, the extreme fire weather conditions that we've seen that have acted as drivers of some of the fires, like the LA fires, are expected to occur on average once every 17 years, and this is an increase of about 35% in frequency. So it's no surprise that regulators have started to demand corporates and financial institutions to incorporate climate risk into their risk management frameworks. However, it is clear that this is more than just a regulatory issue. So climate risk is typically divided into two categories, as Matthew has explained. There is transition risk, and then there's physical risk, which is the type of risk we will be analyzing here today. And this is the risks that arise from the impact of climate events on assets, operations, and supply chains of different corporates and financial institutions. Typically, we talk about two different types of hazards. We have the acute hazards, which are like short-term and sudden events that can cause severe and immediate impacts. Here we have like floods, windstorms, landslides, fire. And then we can also study chronic hazards, which are long-term and gradual changes in climate patterns that take over extended periods of time. So as we've said, as these projections highlight the frequency, the increasing frequency and severity of the different hazard events, we must start as companies to include physical risk into our risk management frameworks. How does physical climate risk impact the financial sector? Actually, it impacts the financial sector through various risk categories, which include market, liquidity, and operational risk. However, one of the most direct transmission channels is actually credit risk. When a hazard event impacts the assets of a given counterparty, this counterparty might have issues with workflow disruptions and also may have some problems when with their capacity to repay loans. Some of the sectors which are most vulnerable are here shown in the slides, include real estate, agriculture, manufacturing, supply chain, and also energy and utilities. And the truth is that when looking into each of these sectors, there's no one rule that serves for all of them. We have to look into each of the sectors specifically and see where the exposures to each of the sectors are. However, there are some good news, and that is that if we can measure this risk, we can build adaptation finance products, we can perform stress tests and scenario analysis, and we can also encourage borrower resilience, and thus we can help mitigate the impact of climate-related hazards on the financial sector. So there are the FISRisk library is one tool that can be used by corporates and financial institutions to actually start performing this assessment of physical risk. Here in the slides that I think are available for you, I've linked both the GitHub repositories for the FISRisk library and the hazard library. This hazard library helps with the onboarding, creation, and transformation of all the climate hazard models to be used within OS Climate and specifically within the FISRisk library. Some of the advantages that come with using open source toolkits like this, I think I can highlight two. One of them is the transparency that comes with using an open source methodology and steering away from black box methodologies and actually understanding the data process from the input, from the hazard itself, and then into the actual impact in monetary value. And the second one is the collaboration of a community of global experts, researchers, and practitioners that are working together to commit new features and to make bug fixes. So I won't go into the mathematical framework, the methodology, the actual mathematical framework behind it, and all the pipelines, everything. It's explained on the methodology that's linked on the GitHub repositories I've referred to before. But I do want to go quickly over the 4 main modules that are used within our methodology. They are the hazard module. This module contains the information about the specific hazard events, typically as a relationship between the frequency and severity of these events. Then we go into the exposure model. This model has the integration of all the information about the assets, operations, and so on. For example, the precise location in terms of latitude and longitude of the different assets to be studied, some description, whether they are industrial or residential assets, and also their estimated values. Then the vulnerability model, which helps map this hazard intensity into the damage that's actually perceived by the assets. And finally, the financial model, which is actually really interesting because what it does is help translate this distribution of impact into an actual distribution of expected losses in terms of percentage devaluation on the original value of the asset. So now I'll go on to explain one of the greatest achievements that has been produced within this OS Climate initiative, which is the creation of wildfire probability maps. We've actually integrated multiple data sources, and we've been able to create one of the wildfire probability maps with one of the highest spatial resolution available. So what we've done is we've integrated these different data sets, including the fire weather index, land cover, information about critical infrastructure and population centers, and also some information from the MODIS satellite data. And we have integrated all this information, and we've been able to recreate some of probability maps for different scenarios and climate projections. So what we've done is we've replicated ECB's methodology, which is based on a paper by Berger. And the actual predictions have been done using machine learning, specifically XGBoost. And we've also used explainable AI to provide interpretable results. This has been done in collaboration, a collaboration between 2 of the members of this OS Climate. Alpha Clima has done all the machine learning creation of the pipelines, but what's been crucial is the tools that IBM Research has provisioned to be able to create this 4-stage data pipeline. So what has been used is the claimed framework from IBM Research, and it has been really useful to build this machine learning and data pipeline. It has 4 stages, starting with the data ingestion, then the transformation. Then we have used this library to train the model, and finally we've gotten to the predictions. So it's been really useful specifically to convert these different Python scripts into Airflow tasks. Now moving on to how could a financial institution, for example, make use of this FISRisk library in order to assess one of their problems, for example, the banking book assessment. So using this library, a corporate might be able to select the different hazards that they want to study, the different vulnerability models for each of the assets or operations, then taking from the banking book the exposures and maturities to select these scenarios and years to be studied. And finally, maybe using an approximation to the actual impact of a climate event over a corporate, what they could use to study how these counterparties are affected might be like the tangible assets to total assets ratio, to see how actually this physical impact is seen over the whole company. Then the calculation of the impact over the different counterparties could be performed also for the different collateralized properties, if there are any. And using all of this information and the FISRisk library, we can get to obtain the exposures, the expected losses, and also the updated collateral value after these different climate events have happened. Now I want to show you this web page here. This is our sandbox of the OS Climate Sandbox. What you can see here is a demonstrator of how the actual platform works behind it. And what you can see here is the different hazards, open source data that is available through the platform. You can see, for example, the riverine information, inundation data. We have different indicators. And if you zoom in into a specific latitude and longitude location, what you can see down here is the actual hazard data, which is this relationship between the frequency and severity of the expected events. We can also make different analysis for different climate scenarios, and we can actually look about to different years. So moreover, one could actually upload a portfolio. Here we have a portfolio that's actually quite big. And what you can see here is that choosing different assets, you can see how the different hazards impact these assets over different scenarios and years. So yeah, I don't know if you want to add anything else, Matt, to this.
No. I think this is a good time to pause. This is everything we wanted to show you today, but we can go back on some of the slides and continue with the demo for anybody that's interested. But I think we'd like to hand it over for some Q&A if there are any questions people have come to hear from us on. Go for it. Is there a microphone we can share around, or I'm going to give you my mic and then.
No problem. I think you all hear me.
Well, I think I think if we're recorded, you probably want to be on live. Yeah.
Introduce yourself. Hi. Yeah, Manuel Martos from Tejeda. I just wanted to know what is the standard or the version, or how do you store data, the actual asset data, but actually also the hazards data?
Okay, well, I'll start, and you correct me if I'm out of touch. So, wonderfully, as part of these collaborative projects, we actually have a relationship with Amazon, their ASDI, it's a Sustainable Data Initiative, and they are actually housing the climate data in their S3 bucket. This is wonderful, and there's as part of the partnership, we can also work on some compute power when we want to develop data sets, for example. The actual challenge around asset data, so understanding, if you are a lender or investor, let's say you're a bank, you should know where your real estate portfolio is. You know your mortgage book, you know your addresses, right? And you can convert that to longitude and latitude through various geocoding techniques. But what you don't know is the location of your corporate assets. And typically, we're not in the space to be data providers of corporate assets. But what we demonstrate is when you know this information, this is how you can connect it together into these open source building blocks in order to make decision ready information. But one of the core fundamental philosophies of what we're doing is not just about climate data and assets, it's about understanding the uncertainty. So sometimes it's actually good to be able to show that you don't know. So if we are basing a lot around the uncertainties. If you know you've got an asset located in a certain area, but you don't know what that asset is it a heavy industrial facility or is it a head office? You can at least play around with open vulnerability models that says to you, this is your level of uncertainty behind what you're playing with. So yeah, this is a continued challenge, but we are under the assumption that it will evolve and get better and better. For example, if you're a bank, you're going to prioritize where you really want to get your data on your asset locations. You can probably make a good start by, people that are onboarding these tools can already start by engaging with their clients and say, we think we see this. We see you have assets over here. These are your strategic assets. Let's start a dialogue, because you're not going to necessarily know the perfect financial decision at this point, but it's the stage at which you can start a dialogue with a client around understanding their exposures, which is critical. the other thing that I'm often asked is why should more financial institutions get involved in this? Well, the real reason is there's going to come a time when financial institutions recognize that they can't just work on pure black box analytics, because this is a highly complicated topic, and with a black box analytic, you don't know your uncertainty behind the measurement. You've got no ability to challenge it. So what the reason why we're opening up a lot of this is that we can provide a sort of a strategic vision for a firm that says we are going to participate and contribute to this open source program, and over time we recognize that we will be able to switch off some of our data sets that we're purchasing through the commercial space and focus on the core commercial ones that they need. So what we've done here is we've built sort of a modular plug and play infrastructure which recognizes that firstly, banks don't want to pay for data that's open. What's the point of going to a commercial service provider when they're just collating open data that's already there? What's the point? That's number one. But also number two is that the modular infrastructure recognizes that there will be some hazards that need to be modeled, such as the modeling of rainfall, like hydrological modeling, is incredibly complicated, and we're not trying to get into that space. So what we need to do in an open modular structure is give people the ability to switch between a paid-for commercial data set and an open data set. But that's all sitting on top of a pre-competitive layer. So that's the fundamental choice. So if people are taking a strategic decision to implement this modular plug-and-play architecture, they can, over time, plug in the best available models and use the best available open models, and then make a more strategic decision about where they source their commercial data sets. Yeah. Use the mic, please. Yeah.
Just to follow up on the question, have you thought on how to integrate the different asset representations into this modular architecture you've built? Not only the climate models, but also assets for different banks and different kinds of assets.
Yes, absolutely. So that's what you do. So you can curate. There are a whole series of open vulnerability models. So these are the models that, once you know that there might be the probability of a flood, right, you have to pass this through a vulnerability model, which Elena showed you, right? And these vulnerabilities, for example, will tell you the level of damage that's going to occur or the level of industrial disruption. For example, a warehouse is going to be far more exposed to a flood or wildfire than a head office of a company, right? So you can access the best available open vulnerability models in the world today. So we're also curating those vulnerability models, which enables you to make that decision when you understand the different assets. For example, on chronic heat, there's really interesting data that we've released. So we've actually downscaled from NASA the heat measurements, and we've converted those into what's called a wet bulb temperature indicator, which tells you the ability that how far the body can work when it's sweating itself to cool itself down. That's called the wet bulb temperature, and there's a point at which you will simply die when you can't sweat fast enough to cool your body down. And we are facing serious heat risk in the world, and that's only going to get worse. So with these, we have the vulnerability models that if you have a high intensity outdoor asset or company that's building, construction, for example, agriculture, if you know your asset type, you know your high intensity outdoors, you can pass that into the model. If you know your low intensity, you can't. So that's the kind of way we operate. And then the idea being that those strategically thinking about this approach will recognize that actually for a severe windstorm event, you might require a more advanced vulnerability model that really understands the difference in different roofing construction or whatever it may be. And the idea is to purchase that, plug in that commercial decision or something which tells you how much adaptation is already in place. But the principle of opening up those building blocks is that we can take a bit more control over that. So what you'll typically find is if you imagine a damage function is think of it as an S curve. You've got a probability that you know something will be damaged, but there's an uncertainty around it, right? And that uncertainty around it, you can then at least visualize on this platform. But when you're working with a commercial partner, they might only make 10 samples through a Monte Carlo simulation through that damage curve. Whereas we know one day that a strategically well-structured financial institution will want to take more control of that calculation and might suggest that we want to do that on 1,000 calculations, right? What's that time? 5 minutes, okay, great. But these are brilliant questions. Please connect with us afterwards. And again, these slides will be released online, and they will give you a lot of access to links and methodologies. But the key thing to remember is that this is not a service provider speaking to you today. This is a community of collaboration that happens to sit on top of a really fantastic ecosystem for collaborating. So that's the kind of people that you're speaking to. So we want to actually encourage more contributors to the frame. That includes universities, research institutions, and more financial firms. Maybe there's time for one or two last questions if there are any. And was there anything you wanted to add at all from?
I was going to say that, the actual challenge, I think, is going back to the first question they asked about how to actually assess the impact over the different counterparties, and actually getting that information. That's not where we are at. That's a work that the company should do. But there's a challenge there to actually find how they're exposed to this type of risk. But I think it's this analysis that needs to be done.
But again, you've just reminded me that's great, because the other point about this is everybody's trying to do the same thing. So it's great to be able to discuss these challenges in a community. For example, how could everybody get together and use a bit of AI, even satellite imagery recognition, to identify strategic assets of a firm? So AstraZeneca, right, may have 1,000 assets around the world, but it might only be the one key asset that we knew under an East Coast hurricane knocked out 25% of a critical drug production. That's the kind of thing you need to know. You need to know that when you look at British Petroleum, you might find 2,000 of their assets are exposed to flood. But if you have an intelligence around what you're doing, you'll look at the fact that all of these are petrol stations and they're not strategic. So this is why we create the community, that we can discuss how to deal with this and how to deal with the uncertainty of not knowing as well. That's just as important as knowing. Great. Please use the mic, and then we better close. Yeah.
Thank you. Davide Garini, KPMG. What is the worst risk you have analyzed according to your experiences? The most difficult risk to consider using your model? Well,
I think to model, and again, we're not climate modelers. Modeling, I think it's hydrological modeling of rainfall. This is incredibly complicated, and we're not going to get into that space, right? That's why we provide a plug-and-play architecture. I think there's going to be continued challenges in calibrating those vulnerability models. That's a significant challenge. For example, the chronic heat model that you see is based on a research paper primarily calibrated around the Americas. So at some point, somebody can take that, and they're going to need to then sort of distribute it, recalibrate it across the rest of the world. And that piece is also quite challenging. I think that we've addressed a lot of challenges in terms of optimizing data sets. So if you think about it, what we've done is we've created the best open way of optimizing and structuring geospatial data files so they can be processed on millions of assets rapidly. So handling that geospatial data is also a significant challenge. And I think to finish with a closing comment, here we're trying to give people the beginnings of the tools. The future is going to be on cross or correlated event hazards. So when you look at what happened in Hawaii with the combined wind and wildfire events, when you look at what happens with wildfires or floods after you've already seen significant droughts occurring, these things are significant. And again, you've got also coastal inundation under wind conditions. So you've got that, I think, is going to be a severe challenge for the future. And I think we will see in the next 10 years or so, we're going to see chronic loss of agricultural production in one region of the world through these sorts of risks. So this is a real problem, and we're showing, as Elena said, we're looking into the future. So how bad is it going to get? And how do you then discount that badness into pricing assets today? So the more to come on board, the merrier. That's a good way to finish, I think. So thanks very much, everyone, and thank you to Elena.
Thank you.